Welcome back. What we have today is fire. Specifically, like last time, we made this fire morph completely in C Sharp based off of another C Sharp program I had written. Transferring it wasn't too hard, and it really is fun that you can take this whole program and just kind of slide it around and it just runs alongside everything else. Anyway, the goal was to see if I can get that same demo running in MiniScript, which is now what we have here in the top left. It is not as fast as the raw C# code, but that's to be expected. I think I got it running about as fast as I care to. Here's what I had to do to make that happen. Okay, from the top-ish. I have not implemented the page up and page down commands in my text editor, which I am currently regretting. All the way up, come on. One of the things is that I tried reproducing the same demo in MiniMicro, and the performance was about the same. You do not want to try filling the entire screen in either program with a pixel demo effect like this. So the width and height 128 by 96 gives a decent performance. It's small, but it works. The bigger you go, the slower it's going to get, and it's going to happen like kind of exponentially. The blend factor is used when we're calculating the fire value per cell per pixel later on. We need a min function. We need to be able to convert from the hue, saturation, and lightness to a color object. Merge together a couple of functions from the C# code to make this. But it's kind of generic math that I pulled from another app that I pulled from a website that probably pulled from another website that probably pulled from some interesting book written in the mid-90s. Create the color object here. Some point, I'm probably going to create some sort of standard library and have the color object just live completely in MiniScript. It doesn't really do much. It's like you don't really need an intrinsic object for color maps. It doesn't gain us anything, I don't think. I'm not sure. I could be wrong. And the array. Originally, I had this generating a two-dimensional array. Create a list for the outer array, and then we add a series of rows. To each row, we push a cell. It's a little bit faster if you do it all as a one-dimensional array, and then do some math to calculate the position within that row. So we don't need those bits. We need to calculate a random integer between a min and max value. Calculating the palette. That's almost directly from the C# code. And we have to track the last width and last height, because if the morph is being resized, those values could change, and there's not really another way to trigger the script to recalculate the size of this fire buffer. Creating the canvas. I might still change this API. I don't know. Have it passing in a list with the width and height. I think I'd rather just have it just pass in the width and height. You don't need a list for that. The update function is where everything happens. Try to detect if there's a change in the size of the canvas. Grab the new width and height. If it's changed from the last width and height. I don't think we need the global to check the globals map for reading. I think we only need to check it for writing. And then if the size changed, then we set the new last width and last height and recalculate the fire buffer. It's initializing it to black. It's not actually resizing it. It'd be nice if it did, but that would be more work than I'm interested in doing right now. Randomize the bottom row. Calculate the position of the row. Write random numbers to it. And here, I merged together the update and draw methods so that we're only iterating over this array once. We start by building that pixels map, or pixels list, excuse me, and caching some values here so we won't have to keep doing it over and over again. I don't think we actually need the modulus there anymore. Let me think. Pretty sure we don't need that. I'm gonna leave it on these just in case I'm wrong. Do all the math here. And then it's like when we update the fire buffer, we're also pushing another pixel into the pixels list. And then for the last row of the pixels, it's like the pixels are being pushed from the top left to the bottom right. So you have to iterate back over that bottom row and push all those pixels up, and then you can tell the canvas to just write all the pixels at once. The canvas still has the set pixel function. It's like you can do this. That works. And that will work. But writing the entire list to the C# side all at once is faster. So that's what I'm doing. And then exporting a step function. So we can choose from the REPL how many steps to take. Now I want that to scoot over. Scoot, scoot, scoot. Now from the top, I don't have a good way of breaking a loop once it starts, so not yet. Another thing for the to-do list. Open the REPL. Run file fire version 0. Take 16 steps. And that's because of the change that I just made. Okay, get back here. I don't know why I insist on making changes in the middle of demos. I don't even know why this is necessary. I need to think about this some more. If y is always in the range of 0 to last height minus 2, then why do we have to use a modulus to keep it inside of its range? Then you scoot, you come back, rerun. And there you go, start stepping. And we can make it a little bit bigger. Canvas, props, size, there's the size, so. Let's say width is 160, height is 120. That was giving me decent results earlier. Move it while it's running. is nice that it's stable like that. And then basically you do this, and then it just runs forever. There is a bug in the REPL loop, like if you're, it's executing the commands inside that while loop while I'm typing them, and it needs to wait until I close out the loop. Anyway, there you go. We have fire. The canvas works. And it works about as fast as I think it's going to. The next step is probably implementing, say, we have a basic kind of tile map. It only accepts one kind of tile. I think I need to expand that. And I'm going to need to implement some sort of sprite display because all of the like managing sprites needs to be something where we set it up in MiniScript and then push the actual like rendering, updating of sprites into the C# end. So that'll be a fun project. Also gonna need to work on like how, like if you click around in here or give it keyboard focus and type, how's that going to interact with the MiniScript code? So more on that next time. Thanks for joining me. See you later.